Hey there guys, welcome back to the channel. We shall move to the next problem. Liquid medium level problem 1026. Maximum difference between node and ancestor. Given the root of a binary tree, find the maximum value. Root of a binary find the maximum value b. So we are given the root of the binary tree and we have to find a maximum value for which there exist different nodes a and b. For two different nodes a and b, B will be their absolute difference and A is the ancestor of B. Okay, we have to find the difference between ancestor and a child node. Actually, it's not a child node. Ancestor and a lineage node. And A and B cannot be same. A node A is an ancestor of B if either any child of A is equal to B, any child of A is equal to B, or any child of A is ancestor of any child of A is equal to B. Okay, or so this means uh, the immediate children or any child of A is the ancestor of B. Well, let's think the intuition first. We have to find the difference between every child and ancestor nodes. So initially we will take root, and as we go further we will check the difference between the child and parent node and return the maximum. So let's start. Also, let's see the constraints. The number of nodes in the tree is in the range 2 and 5000. Then node value will be between 0 and 10 to the power of 5. Now let's define DFS, and node is not node let's think of a way. If we return 0 here, okay, so go left. Yes, I have to pass the parent as well. Dot value. Now if we pass the parent, maximum of left, right, and let's keep it as current, and this as parent minus current and their absolute difference. We're doing something wrong here. Mhm. So let's dry run this and see what's going wrong. So initially we go with 8 and the value of 8. Now the node and the parent are same. Oh, this can't be. So just ignore the first one. Here the parent minus current will be 0 for sure. So the current will be no dot value, which is parent. Now as we go further, we'll have 3. We go to the 3 and pass 8. And we go to the 1 and 3 will be the parent. Since 1 didn't have the left and right nodes, it will return 0. Now the left is 0 and the right is 0, and parent would be 3 and the current will be 1. Let's see. Parent, current, left and right. Okay. 0 0. 3 minus 1 will be 2. And as we go back, we go right. 6 will be the parent for 4 and 6 will be the parent for 7. Okay, I understood the problem, guys. I got it, I understood. 6, 7, 3, and 6. We got 2 and 1 from here since 2 is greater, and we got 2 and 3 here since from the left side we got 2 and the right side maximum will be 3. Fourteen minus 13 will be 1. 10 minus 14 will be 4, and 8 minus 10 will be 2. 8 minus 3 will be 5, and from the right side we got 4 as the maximum difference. But if we see properly, we have 1 and 8 as the minimum child and the maximum, what do we call it, parent. So 8 minus 1 would be the proper answer, and we are not checking it. Uh, I got the problem what's going wrong from like with our code. The thing is we are checking the difference between immediate parents but not the ancestors, distant ancestors. So once distant ancestor is 8, we are not checking the difference between 1 and 8. Well, we can do one thing. Right. Maximum, right? Off. Well, we are passing the minimum left and maximum left, but not. Now this will work probably. Here the minimum is 4 and the maximum right is 7. Now the minimum left is 1. The maximum right is still 7. Oh, okay. Let's pass the one 14. Now let's keep self dot answer equals to 0. Now right. So let's calculate. If we return the maximum answer, well, I guess this will work, but it is not the optimal solution. Wait a minute. No. Okay. Okay, got it, guys. In right, in left, that's left. In right and that's right. Negative infinity. Sorry. Mm, well, it is working fine now. So the difference is 0 here. Now when we hit here, the maximum difference found is okay. I think it is because 7 minus 3. 7 minus 3 it is 3 minus 1 and 7 minus 3, 2 and 4. So we took the 4 and here it is 10 minus 4. Well, let's try submitting it. And let's see what other optimal solutions we can find. Let's submit this first. We made it very complex, but I am like grasping the gist of it. Let's first discuss the intuition and see the answer like others answers. So we initialized a instance method, sorry, not method, instance variable, class variable actually. Like no, it's instance variable. So we initialized it to 0, and we have a simple DFS here, and we don't need the parent as well. Well, where we are not using parent, so by the time we reached the last node, or like if we reached a leaf node and we try to access the left or right nodes, we are returning the positive infinity and as the minimum value, and negative infinity as the maximum value. And we have the current node value. We are checking the maximum and minimum values from the left subtree and minimum and maximum values from the right subtree. And from that, we are taking, like we are checking the maximum minimum values and comparing it with the current values as well. So that this will update, like it will give the maximum and minimum values from the left and right subtrees. And from here, we are checking the absolute difference between the current value and the minimum child and maximum child. So for the current value, we are checking the minimum value from the left subchild and maximum value from the right subchild. Actually, we don't need to do this. You can cut this down, and can keep a, what do we call it? Instead of keeping 4 conditions here, we can just handle it with the 2 conditions. Anyway, let's see other solutions as well. Maximum difference. So instead of doing a DFS, they are doing in a iterative way. They're doing the same thing. They are finding the maximum and minimum values. Maximum difference, the existing maximum difference, and current node minus the minimum value until that point, and maximum value minus current node. So which is the same as ours. I hope you guys understood the intuition. If you like the video, upload it and share it with your friends. Let's take a code review from ChatGPT as well. Let's see what this says. But there are a few logical and structural issues that prevent it from working that tree. Let's review it in detail. Problem, you need to find the minimum difference between the value of and ancestor binary tree. Your approach summary, you use a DFS that returns minimum maximum for the subtree. While undermining recursion, you update self to not node and its subtree. That's conceptually correct. The core logic is sound. However, a few technical fixes are needed. Minimum left and maximum left equal. But your function only accepts one argument node. You should raise a typer. The current, you can compute all you need using subtree values. Oh, I just forgot. So this looks cleaner. So let's see what it is doing here. If not node, it's returning nothing. So dot on circum absolute of node dot value minus current minimum. Oh, it is passing the current minimum in the call itself. Minimum. And some nodes, simpler logic, concise complexity. Well guys, I hope you guys understood the intuition. If you like the video, upload it and share it with your friends, and don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard. Thank you for choosing the channel again guys. Goodbye.